Hello students, in chapter 3 of your matrices and determinants, today we are going to take up the type of questions where you need to find inverse and a matrix A is given to you and you have to show an equation is equal to O. Like for example, this is question number 15 of your exercise, and here the matrix A is given here as your 1 1 2. First column 1 1 2, then second column is 1 2 minus 1, and third column is 1 minus 3 and 3, right? And using this matrix A, you have to show that a cube minus 6a square plus 5a plus 11i is equal to 0, and hence you have to find A inverse. So let us check out how to solve such kind of questions. So in order to solve such questions, firstly we need to understand that how to find your A square from a matrix A, right? So this matrix A is given to you, which is the first column is 1 1 2, second is 1 2 minus 1, and third column is 1 minus 3 and 3, right? So A square can be found by multiplying A by itself. Okay, so multiplication of this matrix A by itself will give you A square, and A cube can be found by multiplying this A square matrix with again A, right? Similarly, A4 can be multiplied by your A cube into A, right? And this is how we can find A square, A cube, and A raised to power 4, right? So firstly we need to solve this expression, right? So given a matrix A, let us start with the solution. So firstly I need to find A square. So A square is your A into A, which is your 1 1 2 1 2 minus 1 1 minus 3 3 into your 1 1 2 and 1 2 minus 1 1 2 minus 1 and 1 minus 3 3. Okay, so let us start up with multiplication. You people are familiar with how to multiply these matrices. So firstly, this is your, you will be getting product as C11, C12, C13. This is C21, C22, C23, C31, C32 and C33. So what does it mean? C11 means first row multiplied to first column will be written here, and then first row multiplied to second column will be written here, first row and third column here. Similarly, second row, first column here, and so on, so right? So we are familiar with this process. So let us start up first row and first column. So it will give me 1 plus 1 plus 2. This will give me 1 plus 2 minus 1. This will give me 1 minus 3 plus 3. Okay, so this is 1 plus 2 minus 6. This is 1 plus 4 plus 3. This is 1 minus 6 minus 9. This is 2 minus 1 plus 6. This is 2 minus 2 minus 3, and this is 2 plus 3 plus 9, right? And we get A square as 4 minus 3 7. Okay, and this is 2 8 minus 3. This is 1 minus 14 and 14. So this is your A square. Now let us find A cube. A cube is your A square into A. So A square is the matrix we still found. This 4 minus 3 7, 2 8 minus 3 1 minus 14 14. Now this matrix is to be multiplied again with your 1 1 2 1 2 minus 1 1 minus 3 and 3. Okay, so let us multiply this matrix. So again this will be 4 plus 2 plus 2. This is 4 plus 4 and minus 1. This is 4 minus 6 plus 3. This is minus 3 plus 8 minus 28. This is minus 3 plus 16 plus 14, and this is your minus 3 minus 24 minus 42. This is 7 minus 3 plus 28. This is your 7 minus 6 minus 14. This is your 7 plus 9 plus 42. And we get a cube as 8 minus 23 and 32. Okay, and this is 7, 27 and minus 30. So, and this is 1 minus 69 and 58, right? So this is your a square and this is your a cube, right? All the values are there. A is already with us. So now I will put it in this expression and then prove that the result is a null matrix, which is represented by O here, right? Now consider the expression that is your a cube minus 6a square plus 5a plus 11i. So a cube is here 8 minus 23, 32, 7, 27 minus 13, 1 minus 69, and this is 58. Minus 6, a square is your 4, minus 3, 7, 2, 8, minus 3, 1, minus 14, 14. Minus 6, a square plus 5a, a is the given matrix, that is 1, 1, 2, 1, 2 minus 1, and this is 1 minus 3 and 3 plus 11 times. I stands for identity matrix of 3 cross 3. Okay. So now we will frame this result and see the corresponding elements. 8 minus 6 4s are 24 plus 5 1s are 5 plus 11. Similarly for 7 it is 7 minus 6 2s are 12 plus 5 plus 0. Okay, so let us go on like this. 1 minus 6 plus 5 plus 0, this becomes minus 23. See from here these elements, plus 18 plus 5 plus 0, 27 minus 48 plus 10 plus 11, that is minus 69 plus 84 minus 15 plus 0, that is 32 minus 42 plus 10 plus 0. Then say this is minus 13 plus 18 minus 5 plus 0. This is 58 minus 84 plus 15 plus 11. Whether we are getting our null matrix or not. So see 8, 5, 13 plus 11, 24. So minus and plus this 0. 7 plus 5, 12. 12 minus 12, 0. Again this 5 plus 1 is 6 minus 6, 0. Again 18 plus 5, 23 is 0. So this say 37, 48, 0. This is 69, 15, 84. This is 0. So 32 plus 42 minus 42. This is 13 minus 5, 18, 0. And this is, okay, this is your 11, 15, this 84, that is 0. So we get a null matrix. Okay, now we have shown that a cube minus 6c square plus 5a plus 11i equal to 0. Now we are not supposed to find now the inverse using this. Find a inverse. Okay, so how we frame inverse using this equation, right? So first of all, given expression you are having, you have to take this term including your I to other side. So it becomes minus 11i, right? Now I need to introduce a inverse here. For that I will pre-multiply by a inverse. So it becomes a inverse a cube minus 6a square plus 5a is equal to minus 11 a inverse into I, right? Now what is a inverse into I? Matrix multiplied to identity matrix is the matrix itself, a inverse. And I will start opening it. 6a inverse a square plus 5 a inverse a, right? And this is equal to minus 11 a inverse. Okay, now start adjusting 1a here into a square minus 6a inverse into a, and 1a I have taken from here, and this a inverse into a is equal to I. So this is 5i minus 11 a inverse. So this becomes I a square minus 6ia plus 5i is equal to minus 11 a inverse. So I a square is a square minus 6, this is a, plus 5i is equal to minus 11 a inverse. So what do we get a inverse as? It is your minus 1 upon 11 times. Okay, this is a square minus 6a plus 5i. So what we can do is we can adjust this negative sign inside, right? So we'll get, now adjusting this negative sign inside, I can write this expression as a inverse is 1 upon 11 times minus a square plus 6a minus 5i. So this is 1 upon 11 times minus of a square matrix, that is your 4 minus 3 7, 2 8 minus 3, 1 minus 14 14, right? Then it is plus 6 times a, my original matrix, minus 5 times identity matrix. Okay, so this is 1 upon 11 times. Okay, so I need to understand that this negative sign is to be balanced inside. So it is minus 4 3 minus 7 minus 2 minus 8 3 minus 1 14 and minus 14, this plus 6 6 12. Okay, we can do it in one round also, but minus 18 plus 18, and this can be written as 5 0 0 0 5 0 0 0 5. Okay, so it is 1 upon 11 times. Now this is minus 4 plus 6 minus 5. So this is minus 2 plus 6 plus 0 minus 1 plus 6 plus 0. This is 3 plus 6 minus 0 minus 8 plus 12 minus 5. Okay, this is minus 5. See from here. And this is 14 minus 18 plus 0. This is minus 7 plus 12 plus 0. 3 minus 6 plus 0. And this is minus 14 plus 18 minus 5. So this is 1 upon 11 times. So what we get? 5 and 4, they are 9. 9 minus 6 is 3. So it is minus 3. This is 9. This is 5. Okay. And here we get 4. This is 13. This is minus 1. This is minus 3. This is 5. This is minus 4. This is 19 plus 18, that is minus 1. Okay. So we get this as the required A inverse, which we compute by using the expression. I hope this concept is clear to you. Thank you so much.